Right. So, bless you. Today we're going to talk about theoretical probability. There are different types of probability, but theoretical probability is the one we focus on in Algebra 2. And when you're finding the probability or the theoretical probability, you're finding the measure of how likely an event is to occur. So the likeliness of an event. And so the higher the probability, the more likely it's going to occur. And one thing we'll talk about today, and sometimes we'll list it all out, is the set of all possible outcomes. That is called the sample space. And for equally likely outcomes, the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of total outcomes. So when you see the word ratio in math, almost always it means a fraction. Not always, but almost always. And I think you learn the most about probability in the 7th grade, but I'm not 100% on that. And so when you learned this in 7th grade, I would guess, I don't know for sure, that what your teacher told you to put on the top of the fraction is number of ways to succeed. So depending on what you're trying to get, what probability you're trying to find, number of ways to succeed in the numerator, and then the total number of outcomes in the denominator. So you'll hear me kind of talk about that as we go through. Now, there are some really common probability questions that we're going to see. The marble question is super common. The juniors in here, which might be all of you, are going to take the ACT in a couple of weeks. And I would be willing to bet there's going to be a marble question on the ACT. So what we're learning now is definitely going to help you with that. So let's look at this marble question. A jar contains 32 red marbles and 28 blue marbles. And then what is the probability that a randomly selected marble is red? So I'm going to set this up as P of red, which means the probability of selecting a red marble. So these are all going to be fractions. And so the top of our fraction is the number of ways to succeed, or the number of ways we can select a red marble, or the number of red marbles. So what do y'all think? 32. Right? And then the bottom should be the total number of outcomes, or the total number of marbles. What do y'all think? 60 total. Now, is it ever going to be possible that the top number is going to be bigger than the bottom on probability? No way. No way. So if something happens, like you do a fraction and the top's bigger, that is not a probability for sure. All right. Now, it's up to you. If you want to reduce that just in your head, you can. Or you can type it in the calculator. So if you want to type it in the calculator, you're going to do alpha y equals, and then choose number 1 to get that little fraction guy. And then you can just put 32 over 60. And your calculator is super smart. It can just reduce it straight for you to reduce to 8/15. Okay, the next one is kind of a, yeah.
What if that be 53%?
Maybe, I don't know. Is that what 32 divided by 60? Yeah, you can get probability as a percent also. Okay. This is another pretty common question. Like you have the letters in a word, and you're going to randomly select a letter, and you want to know the probability that it's whatever. So this word is restoration. We're going to randomly select a letter. We want to find the probability of selecting a vowel. So These questions are going to require you to know things that actually aren't math related. So this one is asking us the probability of a vowel. So you need to know how many vowels there are in this word. So it's like there's 5 letters that are vowels. So that should go in the numerator. What should go in the denominator? Count again. 11. Total number of letters goes on the bottom. Now, I'm not going to type that in the calculator because I know it won't reduce. 5 and 11 are both prime numbers, which we're going to talk about prime numbers in a second too. So I know it won't reduce. If you type it in, it's fine. It's going to give you the same thing again. All right, on number 3, you're going to need to know quite a bit just to do the probability. So a day in the month of January is randomly selected. What is the probability of selecting a prime number? So first, how many days are there in January? 31 days. 31 days in January. So I'm going to list out 1 through 31. All right, and what I'm going to do is I'm going to go back and I'm going to circle all the prime numbers 1 through 31. So do you guys know what a prime number is, like the official definition? Say it again. Kind of. So the official definition, well, I don't know exactly the official, but it's a number that the only 2 factors, the only numbers that divide evenly into it are 1 in itself. All right, so does that make 1 a prime number? No, because prime numbers have 2 factors, 2 numbers that divide into it, and 1 only has 1. So 1 is not. 1 is, I don't know, it's its own number, but 2 is prime. What about 3? Yes. Now, after 2, there is no more prime numbers that are even. So on the rest of these numbers, I'm not even going to check the even because I know they're not prime. 2 is the only even prime number. All right, so what about 5? Yeah. Yes. 7? Yes. What about 9? 9 is not prime because 3 divides evenly into it. What about 11? Yes. 13? 13 is prime. What about 15? No, because 5 and 3 divide into 15, so not 15. What about 17? 17 is, yeah. What about 19? 19 is prime. 21 isn't because 3 and 7 divide into 21. What about 23? I'm asking you to think a lot on the spot, and you probably haven't thought about prime numbers in a long time, but 23 is prime. What about 25? No, because 5 divides into it. 27. 3 and 9 divide into 27. 29 is prime. And 31 is prime. Now, there are other questions on the reviewed or on the notes today and on your homework that ask about prime numbers. So this is good. So you know the first, I don't know, however many, we'll count them in a second, prime numbers there are that you can use to do other questions. So on this one, we want the probability of a prime number. So out of those first 31 numbers, how many are prime numbers? It's 11. out of a total of 31 numbers. All right, let's talk about how many days are in each month also. Now, I still remember how I learned this when I was in elementary school, and I don't know why I remember this because I don't remember a ton. But I remember that you make a fist, and if you go through the months and you're like on your knuckle or in between your knuckle, if it's on your knuckle, it's 31 days. If it's in between, then it's less than 31 days. So, like if you start and you do January is on the knuckle, 31. February is between, so it's less than 31.
Start at February.
What? You always start on a knuckle. So January, February, March is 31. April is less. May is 31. June is less. July is 31. And then you go start back at your other knuckle. August is 31. I don't know. I still remember that way. So the number of days in each month, we'll jot it down in case you don't know. So every other month until, well, I can't say that. August and July are the only ones back to back 31. All right, so you might need that for multiple questions. How many days are in a month? All right, let's look at 4. I'll let you guys get that written down. All right, so 4 is a dice question. Tossing 2 dice forms a lot of probability questions. And so what I have on your little sheet is the different outcomes if you roll 2 dice. I'm going to scroll down. Mine are red and green, but you can kind of tell there's 2 different dice that are rolling. And so for the question we're about to do, number 4, 2 dice are rolled. What is the probability that the sum of the 2 dice on the next roll, I don't know why this is the next roll, is at least 9? And so the sum is when you add them together. So this is a sum of 2, and this is a sum of, those 2 are a sum of 3. These are a sum of 4. These all are a sum of 5. Like you add all the dots together, you would get 5. And so we want at least 9. So what does at least 9 mean? 9 or more, right? 9 is the least it can be. So do you guys see a 9? They should all line up diagonally. Everything that adds equal 9.
There's one at the bottom.
Yeah. This section right here is 9. And then all of these are going to be more than 9. So these are the ones, this corner right here, are at least 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 combinations that the sum is at least 9. So let's get back to where we were. Okay, probability of at least 9. All right, so we said there was 10. All right, so looking at yours, how many total possibilities are there when you roll 2 dice? Anybody? 36 total possibilities. All right, and then that will reduce. You can reduce it by hand or in your head. Either way, you can reduce it in the calculator. Is probably how you want to do it, but that's going to be 5/18 in reduced form. Okay. And the next one is a card problem. And the question is, what is the probability of drawing a heart or a club from a standard deck of cards? So I'm just going to draw a picture. The probability of a heart And then the club, some people call it puppy dog feet, but it looks like that, kind of. I'm not great at drawing it. All right, so I don't know if you know this, but every deck of cards, playing cards, standard deck, has 52 total cards. So that's what we're going to put on the bottom. All right, and if you look at your paper, there are 4 different suits. There's clubs, spades, hearts, and diamonds. There's 13 of each of those. Okay, here we go. Here they all are. All right, so if we want to find the number of ways to succeed with either drawing a heart or a club, how many cards are hearts or clubs total? There's 13 of each. 13 of each. 26, right? So yeah, 13 clubs, 13 hearts is going to be 26 total. Where are we? There we go. Okay. And then that just reduces to 1 half. Oh, and there's a question you guys are going to do that says the probability of a face card. And if you're not comfortable with hearts, you might not know what a face card is, but a face card has a face, basically. And so there's all of these jacks, hearts, jacks, queens, kings. Those are all face cards. So if the card has a face, it's a face card. If you want to, you can do this. Okay, so let's get back to 3 coins. I moved that for some reason. That's okay. All right. All right, so 3 coins are tossed. What is the probability that all 3 land on the same side? So all 3 are heads or all 3 are tails. So what I'm going to do over to this side, and I would write this down because you have more questions about these 3 coins, is write down all the possibilities you can get when you toss 3 coins. So you can get heads, heads, heads. What else can you get? Tails, tails, tails. All right, and then sometimes you can get, lots of times you get a combination of heads and tails. So let's say you can get head, head, tail, head, tail, tail, head, tail, head. All right, and then tail, tail, head, tail, head, tail, tail, head, head. I think that's it. Okay, so we want the probability of the same. All 3 are the same. So out of those different things that could happen, how many had all the same? 2, yeah. So 2 were all the same. Out of how many total possibilities? Close. Should be 8 possibilities. So you count the ones that are heads, 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 and tails, tails, tails. So 1, 2, 3, 4, 6, 7, 8 out of a total of 8. So that's 1/4 probability. So it seems like it's unlikely that you get 3 in a row that are the same, but it's 25% of the time, theoretically, that could happen. All right, and then the last thing we're going to talk about today is the complement of an event. And so the complement of an event is the probability of the event not happening. All right, so since the sum of all the probabilities in a sample space is 1, so if we added up all the probabilities of anything that could happen, it should be 1. The probability of an event not happening is 1 minus the probability that it does happen. And so this symbol that you guys see right here, this symbol, the little tilde, that means not. So we want the probability of E not happening. It's 1 minus the probability it will happen. And you guys have actually done this before, like mostly with the weather. So if you're like, oh, there's a 20% chance it'll snow, what's the percent it won't snow? 80. So like you are actually doing complement of events all the time if you're thinking about the weather. And that's what this first one is about. So we know the probability of snow tomorrow is 7/20. What is the probability it will not snow? So the probability of not snow is going to be 1 minus the probability that it does snow. All right, so that's 1 minus, and then it tells you the probability it does snow is 7/20. So that's going to be 13/20 when you do that subtraction. All right. And then number 8, we a month of the year is randomly selected. Well, luckily we just listed all the months of the year. What is the probability of getting a month that does not start with the letter A? So we're going to do 1 minus the probability that the month does start with the letter A. Okay, so how many months start with the letter A? 2 out of 12. All right, and then you can just let your calculator do that, and you get 5/6 is that probability. Okay. All right, we have a couple more. On number 9, we have this spinner, and it's spun, and we want to find the probability that it lands on a number that is not prime. So probability of not prime is going to be 1 minus the probability of a prime. Now there's, on these ones that are not, there's always more than one way to do it. So if you figure out another way to do it, it's okay. But I want to show you this way. There's other ways that could be faster. Okay, now luckily we just went ahead earlier and we circled all the prime numbers from 1 to 31. So I'm going to go back. I'm going to circle all the prime numbers 1 to 16. So I just circled the same ones that I did earlier. Stopped at 13. All right, so that makes 6 numbers that it could land on that are prime numbers out of a total of 16 numbers. And then when you subtract, that's going to be 5/8. All right. And this last one uses the dice question again. All right, so we want to find the probability with these 2 dice that are rolled of not getting doubles. So it's going to be 1 minus the probability of getting doubles. Okay, so we already did this once, and we know there's 36 outcomes when you roll 2 dice. I'm going to go ahead and put that 36 on the bottom. And then doubles is when you get 2 1s or 2 2s or 2 3s or 2 4s. So yeah, good. There's 6 ways to get doubles. So 6 is going to go on the top. Maybe. There we go. All right, and then when you subtract that, that's going to be 5/6 for your probability. Pretty high, so you're not going to get doubles when you roll 2 dice. It's a whole lot of other things you can get. Okay, let me give you your assignment. We're not going to do all of it